In this video, we look at the very important Leibniz Theorem. Hi, this is Ash with Math Hero Academy. Welcome back. We're gonna start looking at the Leibniz Theorem, a very important theorem in calculus. So let's get started. Hi, we're looking at Leibniz Theorem here. This theorem helps us to find out the nth derivative of two products. So let's say you've got something like x squared sine 3x, okay? And you want to find out, let's say this is y, and you want to find out the third derivative. So first is going to be something, second, and then you want to find the third. And Leibniz theorem just gives you an easier formula to work and avoid errors. So let's look at what the theorem says, and then we'll actually tackle this problem. So Leibniz theorem says you can write this particular piece here as u times v, and then of course u is going to be x squared, and then v is going to be sine 3x. Then the nth derivative, or let's say the third derivative, is going to be, and remember this, 3 times, so you're differentiating 3 times, so you've got 3c0, just write down this way, 3c1, 3c2, and 3c3. And then my favorite way is just to write uv here first, put an addition sign, the easiest way to remember, and then you put the 3 derivatives here, you put 2 here and 1 here, put 1 here and 2 here, and you put nothing here and you put 3 here. And now you just calculate separately here. U prime is equal to 2x, u double prime is 2, and u3 prime is 0. And then you've got v here separately. You put v is equal to 3 times cosine of 3x. This is v prime. And v double prime is equal to 9 times minus sine of 3x. And then v3 is equal to minus 27 sine of 3x. And then you just plug it in here. You've got, of course, let's calculate what is 3c0. 3c0 is going to be 3 factorial by 3 factorial, so that's 1. 3c1 is going to be 3 factorial by 2 factorial, 1 factorial, so that's 3. 3c2 is going to be 3, and 3c3 is going to be 1. So you can see this part here, these coefficients, this coefficient and this coefficient, they're the same value. This coefficient and this one is going to be the same value. So just write it down. It's 1, it's 3, 3, 1. And then you can write u triple prime times v. So you've got 0 times v, whatever that is. So that's going to be 0 plus 3 times u double prime. So that's 2 times v prime, and that's 3 times cosine of 3x. And then you've got 3 times u prime v double prime. So that's going to be 2x times v double prime. That's 9 sine 3x. So that's going to be 9 sine 3x. And then the last one, right, plus 1 u v prime. So u is going to be here x squared times v triple prime is going to be minus 27 sine 3x. So then it's a simple matter. This is 0 because u triple prime is going to be 0, and then this is going to be 3 times 2 times 3, so that's 18 cosine 3x. And this is going to be 3 times 2x, so that's 6x. I'm sorry, and then there's a 9 here as well, so let's make it 54x sine 3x. And then this guy here is going to be 27x squared sine 3x. And so that's how you use the Leibniz theorem. Let's look at another example. Okay, here's another example. Y is equal to x to the fourth power e power x. So here you can use u as, assign u as x power 4 and v as e power x. And let's find this time the, let's go a little bit more ambitious, and let's find the fifth derivative of this, okay? So the first thing you got to do is you got to write down this formula here, 5c0, because it's the fifth, put 5 here, and you're going to have 5 terms exactly. So put in 5c0, put in 5c1, 5c2, 5c3, 5c4, and 5c5. Okay, there's going to be 6 terms. And then you put in u, v, just keep putting u, v here. And then you put in the 5 here, and you put in 4 here, and 1 here. You put in 3 here and 2 here. You put in 2 here and 3 here. And you put in 1 here, and you put in 4 here, and you put nothing here, and you put in 5 here. You can see the sum of these, u is differentiated 4 times and u is differentiated 5 times and v 0 times. So the total of the differentiations is 5, which is consistent with the total product being differentiated 5 times. And here u is differentiated 4 times and v is once. Here u is 3 times and v is 2, and u is 2 and v is 3. U is 1 and v is 4, so the total is still 5 in each of these terms. And so let's look at what each of these derivatives is. So let's look over here. You've got u prime is going to be 4 times x cubed. U double prime is going to be 12 times x squared. U triple is going to be 24x. U 4 times is going to be 24, and u fifth time is going to be 0. And of course v, I took an easier example, so v is e power x, and all the derivatives are going to be equal to e power x. So let's put in the numbers here for 505, C1, 5C2, because those are the ones you'll have to calculate, and that's 5C0 is going to be 5 factorial by 5 factorial times 0 factorial. That's always going to be 1. 5C1, I'll leave it with you, it's going to be 5. 5C2 is going to be 5 factorial by 3 factorial, 2 factorial, so that's 5 times 4 by 2. And then the other ones are kind of gonna fall in place the way I'll show you. So the coefficient 1 is here, and similarly this coefficient here is going to be the same as this one here, so you can just as well write right away. 5C1 is going to be 5, and so you can 5C4 is going to be 5 as well because of the symmetry. 5C2 is going to be here, it's going to be 10, so you can just write 10 here and write 10 here. And now you've got u differentiated 5 times, and you know it's 0 times v, and of course there's a plus here, there's always a plus here, plus here, plus here, and plus here. And so you got u differentiated 4 times, you got 24, so times 24 times v prime, and that's e power x. And here you got 10, u differentiated 3 times, so that's 24x. And that's e power x again. And you've got u differentiated 2 times, and so that's 12x squared, and that's e power x. And you got u 1 time, so that's 4x cubed. times e power x, and then you've got u, which is x power 4, and then you've got e power x again. So this is going to go to 0, and you've got 120 e power x plus 240 x e power x plus this was 10 times 12, so that's 120 x squared e power x, and here you've got 5 times 4, so that's 20 x cubed e power x, and here you've got x power 4 e power x. So that's how you can use Leibniz to solve this particular antiderivative of this function. Remember, you can take u and v any which way you want. You could as well have taken u is equal to x and v is equal to x cubed e power x, but that would have still been a bit difficult. I think the easiest one still would have been u is x power 4 and v is e power x.